Welcome back. So, the point where we left in the morning about what was the ideology for industry restructuring will continue with those issues. So, as part of governance, as a part of industry engagement, are you able to hear? Are you able to hear? Are you able to hear? So, as a part of industry governance or industry management, the thought process to structure the industry or restructure the industry evolved with an aim to make the industry efficient, and the aim was rooted through the thought process of creating competitive markets for whichever portion of the vertically integrated supply system, whichever portions were amenable to competition. And tools to achieve those competition was to restructure the industry, provide open access for stakeholders both on the supply and the demand side, and deregulate the industry to the extent possible. If anybody has any questions on what was taught in the morning, I'll be happy to take up those. Anyone has got any further questions? The changes, as we discussed in the morning, the changes related the changes were related to we could restructure the industry because of several changes that started happening in the industry. One was the improvement in materials. The other was because of remote operation and control, because of the computerized system, because of digital communication. All those things, they supported the opportunity to create a restructured supply system wherein one part could be separated out from another part, and further coordination between different verticals could be eased. So as we moved ahead with this, as we understand the drivers for restructuring, it was possible to build new power plants, smaller power plants, closer to the load centers, and industrial consumers, they could start developing, they could start building their own captive power plants. This gave them the opportunity to get electricity supply from those captive power plants to the extent possible. And whenever there was a shortage of supply, they would get the supply from the grid. But as these thoughts got extended, that required to change the industry structure so that those large consumers and possibly small consumers also could access the network and get supply from energy supply from far away generators as well, provided open access was made available on the network. The overall aim was obviously to create competitive markets, to optimize the resources in their own local optimization mechanism rather than trying to do a global optimization for the vertically integrated industry. The aim was that every stakeholder, every player in the system would try to optimize its own behavior, try to optimize its own cost. And when it is participating in the market, it would obviously try to keep its price at a level which would optimize the cost of the people who are purchasing the electricity. So in a way, it would eventually lead to an ecosystem in which the suppliers or the suppliers of the services, the generators, would be forced to supply, forced to provide that commodity at rates which would be competitive. And those rates would obviously be reflective of what the demand supply balance would be. In case there is an excess of demand, that would enhance the market prices, thereby resulting in an increase in the investment. And if there is an excess of supply, further investment in that sector, in those services, would be subdued. So that would give the right economic signal for the investors to invest and for the consumers to buy accordingly. This essentially required that the utilities should be unbundled such that each vertical in the supply system could play its own role. Generator could play its own role. Transmission system provide services as per their characteristics. So also distribution systems. And wherever there would be network, wherever there would be a monopolistic network, those areas, those domains would be regulated. They would be regulated to the extent that the prices that come out through regulation would be reflective of what the prices should be, as though there was competition in the market. So competition, the regulation would provide prices equivalent to what competition would have provided. For doing all this, obviously open access was required. Eventually, still, the aim was to have public good. When it was vertically integrated, when it was a socialist thought process, there also the aim was to have public good. Here also, while we are moving towards a market economy, the aim is not to make profit for certain entities, but to ensure that people compete with each other and provide those services at competitive rates, thereby ensuring that the benefit of competition is passed on to the consumers and public good is also ensured. This would obviously lead to fair pricing of the commodities, and through appropriate regulation, you could ensure that the quality of service being provided to the stakeholder, to the users, is maintained. And obviously, it would increase the investment into the system. And when the investment would happen, that would be efficient investment, leading to leading to enhancing the efficiency of the whole supply system. So this process of creating competition was embedded in three sub-processes. That is, one was industry restructuring, changing the structure of the industry, combining some with others, and bifurcating some others. The aim was to prevent any discriminatory behavior between players. Open access was a mechanism to provide access over the network in a non-discriminatory way. So generators could supply power over the network to consumers, large consumers, in an open market, in a transparent way. That required open access over the network. So as you can see in the slide, it allows consumers more than 1 megawatt power to directly buy cheaper power. Presently, the limits have significantly been reduced. Though the conventional consumer still purchases from the discoms, but it still has the opportunity to buy it from faraway generators as well, provided the cost effectiveness is ensured. In this process, while we were creating markets for those segments where we were creating markets, the aim was to deregulate the market. Deregulate in the sense that regulation in those sectors where competition could be brought in, there the interference of the government should be reduced to the extent possible. Control over the prices and entry of market participants, that should not be too strict, that should be removed. And they should be allowed to operate with minimum licenses possible. So this eventually followed the path of liberalization that was happening in the industry in 1990s and 2000 in India. Aim was similar to attract more and more investment, provide consumers with choices. Essentially, the competition was getting created on the generation side, and transmission distribution side would continue to remain as monopolies. In this process, part of the entities, some of the entities, some verticals of the entities were to be privatized. Um, some were corporatized. They would start working as corporates like Power Grid. Somewhere at some places you would see that the distribution licenses have been given to private entities like that in Delhi and Mumbai, where the private players, they handle the transmission and the distribution business, local transmission distribution business. Um, so different versions of restructuring evolved in different parts of the country, and so also different parts of the world. Depending upon the time scale and depending upon the country where they were working, the pathways taken for industry restructuring were different. That depended upon what the government's thought process was, what was the status of the industry in taking up the initiatives, and many other things. As a part of restructuring, the first thing that happened was unbundling of the vertically integrated supply system. Unbundling would essentially mean splitting or breaking the business into different parts based upon the functions that they perform. So when we talk about unbundling here, we would separate out the generation business from the transmission business, from the distribution business, from the retail business, and thereby a customer would be interacting with the different verticals separately. It could pick up one or more of these entities to secure supply, rather than the earlier situation in which he was only talking to the state electricity board as a single entity to secure its energy supply, wherein it did not have any opportunity to participate, to get energy supply from competing market players. In the present unbundled scenario, the customer would have a choice to get power from retailer A, B, or C, and possibly he can choose, if it depends, he can choose which generator would be supplying him power: generator 1, generator 2, generator 3, generator 4. It would depend where he would like to buy power from. This creates an opportunity to unbundle the system. Two types of restructuring happened in the system. One was vertical separation of the entities. The other one was the horizontal separation of the entities. When we talk about vertical separation of the entities, it essentially reflects to separate out the generation, transmission, and distribution business into different verticals, depending upon the functions that they perform. It would create transparency between different verticals, thereby enabling the stakeholders to understand what is the cost of generation, what is the cost of transmission and distribution separately. Horizontal separation would mean breaking the industry of one vertical, let's say generation, into smaller parts which compete with each other in a competitive market, so as to provide those services in a competitive marketplace. So two type of separation, two type of unbundling happened in the industry. While competition was being attempted to be created, not all portions of the vertically integrated industry were amenable to competition. Like generation, their competition could be introduced. Introduction of because of new generation technologies, production of good quality power, and some power plants were able to produce electricity at a significantly different rate from what was being produced at generally by the grid. Transmission and distribution systems were what we call as natural monopolies, because in those areas you could not have multiple network providers providing services, because only one set of wires could run along the path So only one entity could be given the license to transmit or distribute electricity. So the right of way could only be given to one player at any given point of time or at any given point of space at any given geographical location. And physically there would be limitation. You cannot have multiple transmission lines running in front of your houses because there is a limitation on the roadside. And obviously the investment is so heavy that it would not create opportunities for multiple players to invest and get return on that, because the capacity utilization of those networks was not very good. So when you are investing into a network wherein you are not utilizing the full capacity of the network, obviously if you create a parallel network, parallel supplier who is supplying the network, anyways the cost of supplying the network by a single player would always be less than that of being provided if the same services, if the same network services are being provided by multiple players. So even if you create multiple players on the network side, eventually only one of them would survive, rest all would have to close their business. System operation as a part of controlling and observing the different stakeholders, how much a generator is producing, how much the demand and supply, all those are critical roles for the security of the system. So for better control and security of the system, only one system operator is kept at any given point of time. The system operator observes and controls the generation and demand at all nodes and manages the balancing between the generation and demand for the system. So essentially, we would have no competition in system operation, but only a single player who would provide the services of system operation. Eventually, how it would evolve into is separate generation companies, transmission companies, distribution companies, retail companies, customers, system operators who would manage the system, and market operators who would manage the market. We'll get into these one by one so as to understand what is the role of each entity and how, what are their aims and how do they work. So when they are being bifurcated, when they are being unbundled as generation, transmission, distribution entities, the generation entities are supposed to own the power plants, of different technologies. In order to run those power plants, they buy raw material like coal, oil, gas, or biomass or any other raw material from different markets, and they sell electricity in the wholesale market. So on one side, they do the purchase of raw material or fuel. On the other side, they sell the finished product or electricity in the market. They sell the electricity. They have the opportunity to sell electricity via multiple ways. Competitive markets could be one of those. Apart from power, now the opportunity that arises is because traditionally all contracts are focused towards power. Now they would have, and now when it is not a vertically integrated industry, there some of the services which were earlier being provided by the vertically integrated industry, the state electricity boards, will now not be provided by the system. So that creates a need to provide ancillary services as well into the system, and like reactive power and other ancillary services into the system, which are not provided through the traditional competitive markets for electric power. Affiliations, the generators are competitive in nature. They own their own responsibility, but they do not have a liability to fulfill the demand supply. They have a liability only towards fulfilling their own contracts. So as a generator, if I've contracted to supply 1 megawatt, I'll only supply 1 megawatt, irrespective of whether I've got additional capacity available with me or not. I would not tend to supply or inject power for the capacities which I have not contracted for, because I would not be compensated for those. So essentially, my role as a generator would be limited to only fulfilling my contracts. And my role with the earlier role as supplying the demand, that role is now done away with. That responsibility now passes on to the system operator, who is now responsible for managing the demand supply imbalance. Generating companies, they would coexist with vertically integrated industries. That is the present scenario. They could engage themselves in arbitrage. The prices, because they are not regulated, their prices are not, because they are not regulated entities, the prices would not be regulated. They can participate in the market through bilaterals or through bids, through open exchanges, as per their choice, as per the prices that they would like to offer. They also have to manage the assets of the entities, manage the assets of the power plant that they are owning and operating. If anybody has any questions up till now, any questions, anything that strikes you, which you would like to ask? So moving beyond the generators, we have got transmission companies. Transmission companies are entities which provide transmission networks. They perform functions like building the network, owning the network, maintaining the network, and operating the network. Along with providing the network, they also provide system reliability services. So, as you see in this ownership block, they perform multiple functions. It is, when we say transmission network, it is not only that they have the network, they own it, they maintain it, and they operate it, essentially doing multiple functions at even while they are providing transmission systems. Uh, Transmission systems provide the pathways to transfer electricity from generation side to the distribution side. Essentially, they are high voltage bulk network systems. They provide open access over the network so that any utility which wants to sell electricity over the network can sell electricity. Any user, any consumer who wants to buy power over the network can do it in a transparent way at prices which are openly, transparently visible. Transmission companies cannot have common ownership with the gencos or the retailers because they are supposed to be neutral to either sides. They do their asset management, owning and operating their assets, managing the assets. Since these are monopolistic entities, they have to be regulated. On the transmission side, they have to be regulated by the central regulators. On the state side, they have to be regulated by the state regulators. And the regulation is there to ensure that they provide non-discriminatory access over the network. The prices or the charges that they charge for providing the network are supposedly designed in such a way that they are able to recover the investment or the cost involved, investment as well as the operation cost involved in providing those services. Various charges, we'll be deliberating upon those possibly. Various charges could include charges for accessing the network, charges for using the network, and charges reflecting the congestion in the system. So depending upon the complexity of design that you want to create, you can have simple systems, simple charging systems in which only the transmission usage charges are levied. You could have additionally access charges in the system, or if you want, you can also have congestion charging in the system. These three reflect three scenarios in which transmission usage charges essentially reflect how much of network anybody is using. Access charges are charges which would depend upon where you are connecting to the network, whether you are connecting to the network at 11 kV, 33 kV, or 230 volts, and whether for your connection, for you to connect with the system, was there a need to make any additional investment? Was there a new line that had to be put in, or a new transformer that had to be put in to provide you connection? Congestion revenues could be reflective of these charges could be reflective of the network congestion in the system. This congestion obviously is dependent upon the market prices of electricity at different nodes in the system. So if there is any network in the system which is already congested and you want to transfer power over that network, so you would have to pay higher prices for transferring power over that network in a way similar to that we do on roads where there is congestion, the toll charges or the if you are hiring a cab, the cab charges would obviously increase in case you are traveling through pathways which are congested or where the traffic is high. Similar to transmission networks, we have got distribution networks which own and operate the local lower voltage power system. They have monopoly in operation at the local level. Essentially, they supply the wires and they also supply, traditionally they do the supply business as well. These are regulated because these are monopolistic businesses. Presently, they do not have competition, but as and when retailers are created in the market, they would have an opportunity to compete with each other for selling electricity. They would obviously, these distribution companies, if they are unbundled, they would get unbundled as network separately, the power supply business separately, and the metering business separately. They'll obtain the revenue by wheeling electric power through their networks. Essentially, they are responsible for building and operating the electric systems at the lower voltage level and maintaining and providing voltage support as well as customer support to the consumers. I think there was a question. Kush, could you just highlight what the question was? What will be the role of power exchange in open access? With the integration of renewables, how will it affect the open access, especially in case of congestion? We'll come over to that question slightly as we discuss specifics of the power exchanges and open access. We'll come down to that question. Give me some time. Coming down to the retailers, if you are if you see in this slide, if you are unbundling the discom business into the wire business, supply business, and metering business separately, then it creates an opportunity to have retailers in the system. Retailers essentially do the power supply business along with the metering part. So they would not own the network. The ownership of the network will remain with the distribution companies. These retailers would only buy power from the generation company. They would transfer the power over the transmission and the distribution network. Once they are able to transfer the power, they will sell the power to the consumers who are connected with the local distribution network. Essentially, they would not own any part of the network. They would only buy power from the suppliers and sell power to the consumers. In that way, they would make a profit by having some margin in the selling price over the cost price. So that would give an opportunity to have multiple retailers in any geographical area. And the consumers, as you presently have got the opportunity to get mobile communication from different SIM providers, different network providers, in a similar way in electricity sector, as a consumer, you would have the opportunity to connect to a retailer of your choice. It could be retailer A, retailer B, or retailer C. All the three retailers would be willing to provide power at your household over the network of transmission and distribution while they are buying power from one or more generation companies in a market. This gives the customers the choice of retailers, which retailer to buy from. At some places, these retailers could be subsidiaries of generation or distribution companies. Ideally, they should be separated out. These retailers may indirectly coordinate with the consumers through aggregators or directly through consumers as well, directly with consumers as well. Both possibilities exist. Although the new business models come up, the retailers could combine electricity products with other services and combine them as a package deal in the same way as we get package deal while we recharge our phone with prices like 199 or 299, which provide us a bundle of services like calls, SMS, internet, so on and so forth. In a similar way, retailers in electricity supply system could bundle one or more services to be sold as a bundled service, and customers, the way by which they choose their suppliers, depending upon choose their suppliers or the the bundle of services that they want to buy. In a similar way, they could do it in electricity sector as well. The questions that I see here, one is how Gencos fix the cost of power under PPA. Is there any role of CRC on it? Essentially not. Gencos, the present day Gencos, if they are merchant generation companies, they do not have any obligation to do a contract. They can sell their whole of power generation into the market at market prices. If they are not merchant generation companies, if they are something owned by Power Grid or otherwise with NTPC or otherwise state-owned entities, they usually do PPAs with these generation companies. They do PPAs with the distribution companies over a long time frame. While they do a contract with those, while they do these PPAs with the distribution companies, essentially they also have a third party involved, which is the network, which is the transmission network as on date. So usually a generation company like NTPC would do a contract with a utility like, let's say in Rajasthan, Jaipur Vidyut Vitran Nigam Limited, along with the third party, that is PGCIL, so that PGCIL provides network access when they want to inject power into the grid. In this scenario, the prices in either of these scenarios, the prices of electricity are not fixed. The CRC does not have any role on fixing the prices of the power that these Gencos would be selling. Another question that I see is retail company can say it is distribution franchise. No. Distribution franchise is a slightly different model. The present day distribution franchise that you see in the country essentially have a geographical license of providing electricity in certain cities, like in several cities across UP, in Rajasthan, like in Bharatpur. The local distribution company, local network, as well as the retail business is with the distribution franchise. So essentially the distribution franchise, which are present day distribution franchise, do the same functions as being done by the distribution companies, the Vidyut Vitran Nigam Limited in Rajasthan. Their functions are essentially not separate. They are only working as a sub-licensee of those distribution entities, however, performing all the functions of the distribution licensee, and they themselves are called distribution franchisee. Although they have not separated out the retail functions and the network functions for these entities as of now. If they become a retail entity, obviously there would be multiple retail entities in a single geographical location, and those would definitely be separated out from the company, the entity which owns the network. I hope that answers the queries of Mani Sagam. Moving ahead with there's another question. Can retailers purchase power from users or only sell? This is depends upon which country you are talking about. Usually, retailers, when we use the word retailers, they essentially are supposed to buy power from the generators or the market and buy power in wholesale and sell it in retail. However, they also have the opportunity to buy power from consumer side as well. However, when they do it in that fashion, they should not be called simply as retailers. Their function changes from being a retailer to what we call as aggregators. Because when they are buying power from consumers or the user side, obviously a small user does not have the capacity to provide large quantum of power. And in an effort to buy power from those consumers, the only option left with it is to buy it from a large number of consumers by aggregating. So in some of the markets, the retailers are allowed to do the function of aggregation, wherein they buy power, small quantum of power from the consumers. And in some of the markets, aggregators are different entities from the retailers, and aggregators are only supposed to buy power from the users, from the consumers, so as to provide certain services to the grid in a way similar to that being provided by the generation companies. So it depends which country we are talking about. Usually the term retailers reflect the process of buying from wholesale, selling it in retail. However, they have the opportunity to buy power from the small users, consumers, and aggregate it. And if these are separate functions, they would simply be called as aggregators, and retailers would be a separate entity altogether. Going beyond that, there's another question. In India, as a retailer, can I purchase from prosumer or janitor and sell the same to individuals from one part of the country to other areas? Do we need to get any license from GOI? I'll repeat the question. In India, as a retailer, presently, we do not have retailers in place. This is one part. We have got distribution companies or we have got distribution franchises. So retailers as of now don't exist. But whatever framework exists as of now, if a retailer is created, can it purchase power from a prosumer or a janitor? Yes, it can buy power from a prosumer or a janitor. Prosumer, in case the prosumer has the capacity to provide that power, and if not, it could aggregate the power from a large number of consumers, in which form it would be more of an aggregator rather than a retailer, and sell the same to individuals from one part of the country to other areas. Yes, very well. You can sell it to other parts of the country using open access. Do you need to get any license? It depends. If you are operating only in a specific state, buying and selling only in a specific state, what our understanding would be that you would need to get a license from the state regulatory commissions. However, if you are using the network, interstate network, and buying power and selling it in other state, you would need an interstate license from the Central Electricity Regulatory Commission. Presently, the regulatory commissions, they hold the key to give the license and not the government. As we move at the independent system operators are basically You could visualize them as the control rooms, which keep on observing what is the generation being injected at the generation nodes, what is the demand being withdrawn from the load nodes, and balancing the supply and demand at all points of time, ensuring that congestion does not happen in the system, and being a neutral player in the system, owning no assets and no profits to be offered. It only has got computing and communication assets, fixed assets, no profit motive, no revenue related to the quantum of power that is being transacted. However, they get a certain fee based upon the power that they are handling. The functions are to ensure reliability and security of supply. They do the control, coordination, and monitoring of the power sector. They manage the congestion. They perform optimal power flow to optimize the cost. They, they coordinate with different entities for providing stable operation. In case ancillary services are not being provided through the market or not being provided by the generator suo moto, the system operators may have to perform the role of as last residuary to provide those services through certain contracts in the market. These system operators could be classified into two forms. One could be transmission system operators. The other one could be independent system operators. There are others also which we have started talking about, that is distribution system operators, depending upon whether you are an entity which owns the transmission system and is also doing the function of system operation. Distribution system operators essentially would reflect a similar scenario on the distribution side, wherein they own the network, maybe or maybe not, but do the system operation on the system side, on the distribution side. And independent system operators could be in system operators which do not own the networks, but simply do system operation without any profit motive in the system. They have the authority to commit and dispatch some or all system resources. That means they can decide which power plant would produce how much power at any given point of time. They can curtail loads for maintaining the system security. They can procure ancillary services like reactive power, like emergency services and other services at market rates or through bilateral contracts. They are supposed to be neutral players in the system. Essentially, if you talk of India, the Power System Operation Corporation or the Grid India is essentially which is the system operator. It is an independent system operator. It does not own the network assets. It only owns the control rooms, the National Load Dispatch Center, and 5 regional load dispatch centers in different regions of the grid, and thereby observing, managing the grid through managing the generation and demand at different nodes. Moving beyond that, we also need an entity, what we call as a market operator. A market operator essentially provides a platform, a computerized platform to provide for the buyers and sellers to sell and buy electricity. It is basically a online platform where buyers who want to buy electricity can fill in their offers to buy, and sellers who want to sell electricity can submit their offers to sell. So these offers, the bids and offers are submitted on that online system. There's a computer or some server at the back end that does the processing, and it matches the demand with the supply. And once the demand and supply are matched, it passes on that information to the system operator, who in turn passes on the information to the sellers and buyers for injecting or withdrawing from the grid. These essentially run ahead of delivery time. So they offer products like day-ahead markets, week-ahead market, month-ahead market, and different forms of market depending upon how much is the market evolution. That could be power market, there could be ancillary services market, and there could be others as well. Usually, the dominant market is that of day ahead, in which they do the trading one day ahead of the actual delivery of power. So, if you want to deliver power tomorrow morning at 10 o'clock, possibly you do a trading today morning 10 o'clock, so that you do the trades, the market operator settles which trades have to be done, which trades can be done. It coordinates with the system operator, it passes on that information, and the real time it coordinates with the system operator, thereby providing a mechanism by which the commodity, electricity, or ancillary services could be bought or sold at competitive prices in the market, and those signals, that information can be passed on to the system operator to manage the system demand and supply. As we were discussing, one of the questions that somebody has asked, whether you could aggregate those services. Yes, we can aggregate. The aggregators are, again, they work along with the retailers. They are entities and firms merging large number of consumers into buying as a group or selling as a group. So these retailers could purchase or sell. Basically, they'll secure services from small consumers in large numbers, so that the same commodity can be sold in the market, in a wholesale market, at a competitive price, when the generators are not available to provide the same services at those competitive prices. So essentially, these aggregators, they provide aggregated response to the system operators, or maybe to other players who are not able to fulfill their contractual agreements. So they essentially work as a broker, as an agent between the customers and the retailers. They have a profit motive to make money. They do these type of aggregation businesses. They stand somewhere between the customers and the retailers and the distribution companies. So aggregators could secure or provide services to the consumers. They could secure services from the consumers, aggregate it, and pass on those services to the retailers or the distribution companies, or to the system operator as well. NLDCs and SLDCs are coming in which categories? LDCs are load dispatch centers, the National Load Dispatch Center and State Load Dispatch Centers. Essentially, the National Load Dispatch Center and the Regional Load Dispatch Centers, they come under the category of system operators as independent system operators, because they are separate from power grid. However, the state load dispatch centers are a part and parcel of distribution companies, are part and parcel, sorry, not of distribution, of state transmission companies, thereby working as, I would not say a independent system operator, but a transmission system operator, though the voltage levels are sub-transmission voltage levels, but still their operation mechanism, because the state load dispatch centers are owned by the state transmission utilities, so they should essentially fall into the category of transmission system operators, while the national load dispatch center should fall into the category of independent system operator. Please, there is a question, please cite some examples leading to periodic variation in load demanded, which would make day-ahead trading profitable for market operators. Not many such examples. One very simple example is during the daytime at around 2 o'clock, present scenarios, you've got large quantum of solar generation being injected into grid, leading thereby to situations wherein the prices of electricity in the market go down to the level of 1.5 to 2 rupees per unit. During the evening hours when solar generation is not available, the prices of same electricity, because the demand has increased, solar generation is not available, the price of electricity boils up to 5-6 rupees per unit. In such a scenario, it makes value to buy power during the daytime and sell power during the evening hours. This could be done through some storage mechanism. These storage mechanisms could be battery storage, or even those could be banking facilities for hydropower plants. Let's say, take an example of storage. The BESS, the battery energy storage systems, could charge their batteries during the daytime at a cheaper rate of 2 rupees per unit and sell that same electricity into the market at around 5 rupees, 6 rupees per unit during the evening hours when that solar generation is not available. So this is a very classical, common example nowadays, wherein the periodic variation in load demanded and the variation in generation available helps the stakeholders to buy in cheap and sell, and it makes value to participate in the market, to trade in the market at different points of time. Moving ahead, when we have got parts of the vertically integrated industry separated out as networks, and part of the industry like generations being separated out as being competitive, the network businesses are essentially non-competitive businesses, while generation business is a competitive business. Though we talk about reducing the regulation, we talk about liberalization, we talk about deregulating the industry. However, in order to have rational economic prices for the networks that we are using, you need to have a appropriate regulator in place which decides the prices of the network over which power is to be transferred. So you need a good regulator to manage the quality of services being provided by the network owners, and to decide the prices, which are reflective of the cost of providing those services. Essentially, these regulators are independent government bodies which are not directly controlled by the government. These regulators are supposed to provide fair and efficient operation to the stakeholders. They are semi-judicial bodies. They would have quasi-judicial powers, having the power to penalize for non-compliance of their decisions. They would be operating at the state level and the central level. The state level regulators being called as state electricity regulatory commissions, and the central level being called as central electricity regulatory commissions. They determine the rules, they determine the tariff. In the state level, they determine the tariff for generation, transmission, and retail, or for distribution. At the central level also, they would determine the tariff for the transmission network Retail obviously does not come into the picture. For the generation companies, they can do, provided they are operating in a traditional PPA mode. These regulators essentially follow the spirit of the Act and develop subsidiary regulation based upon within the outlines defined by the Act, so as to clarify or detail out the provisions being laid in the Electricity Acts such that the subsidiary regulations are able to handle the day-to-day functioning, the day-to-day challenges, and day-to-day, if there are any issues, to sort out those issues. The subsidiary regulation is able to handle those issues in a way by which the stakeholders would not have to go to the court or need not go to the higher authorities to resolve those issues. Now we also have got these two entities, consumers, small consumers and large consumers. They existed in the system earlier as well. Now also they exist. Small differentiation, why we start using the term as small consumer, large consumer. We need to differentiate those primarily because large consumers buy power in bulk, small consumers buy power in small quantities. You and me are small consumers. Industries would become a part of large consumers. Industries or large consumers would typically be connected to the system at higher voltage levels. They could also connect directly to the transmission system, need not connect through the distribution system. Small consumers essentially connect to the distribution systems. Small consumers would not have the ability or even the interest to participate in the markets, especially the wholesale markets, whereas large consumers would have the interest to participate in the markets, in wholesale markets, though these bifurcations are getting blurred over a period of time as new market segments like local energy markets are coming up, in which case even small consumers would be able to participate in the markets. So these are some of the entities that come up as industry is getting restructured, as industry is getting competitive in some of the verticals, as industry is getting deregulated, unbundled, and so on. The roles of these entities has to be understood, and their positioning in the system vis-a-vis how they were positioned in the system initially. Initially, these generators would be generating the power over the transmission distribution network to the consumers. The distribution company would be providing services to the consumers in terms of metering, in terms of fault repair, and the consumers would be making the money payment to the distribution companies, transmission companies, and the generation companies. Over a period of time, as the industry gets restructured, the generators could be supplying power into the market, where with the help of platforms like market operation and system operation, the power gets transferred over the transmission network to the distribution network, which then gets transferred over to the consumers. We would have retailers as well. These retailers could exist parallelly with the distribution companies. The distribution network owners could be separated out, in which case the retailers would be transferring power bought in the wholesale market over the transmission and the distribution network to supply that power to the consumers. Along with the retailers, we could also have these entities, aggregators, which get the services or provide services between these stakeholders, between distribution, retailers, system operator, or consumers, and so on. So this increases the opportunities for different stakeholders to interact with a larger number of players, both vertically as well as horizontally, and secure services from service providers, which are the cheapest, which are the most economic, which are the most reliable service providers. So rather than having a global optimization of networks and generation portfolio, we head towards a system in which the generation companies do their own optimization of cost for generation. The retailers would do their own optimization of buying cheap and trying to sell at higher prices. Similarly, aggregators trying to buy cheap, selling at higher prices. Customers trying to optimize their cost by buying as cheap as possible. Generators trying to maximize their profit by selling as higher as possible, so on and so forth. Thereby, every stakeholder, except for the case of system operator, every stakeholder and the regulator, every stakeholder trying to maximize its own profit. This, as I just discussed, requires deregulation in certain parts of the industry vertical. This deregulation is essentially focused on the, the generation side, where competition can be created, markets can operate, and the prices that would come out would be through appropriate market design. So here the role of regulation is limited to developing an appropriate market design, removing the present control on prices. The prices will be decided by the market, but the role of the regulator is to have an appropriate market design in place and to ensure that the entry and exit of players in the market is unhindered. People can come, people can participate in the market. Those who don't want to participate, they can move out of the market. So in order to do that, you'll have to reframe the rules. You'll have to develop economic incentives, the way by which the government would like the industry to evolve. However, while we are deregulating, the government's interference in deciding the prices would be done away with. It would provide more freedom to the stakeholders, more freedom to the suppliers to decide the prices at which they want to sell. The regulator can at max fix caps at the higher side or the lower side if it feels so, in order to ensure, in order to protect the interest of the consumer or the suppliers. It can develop, regulator can develop mechanisms to create more competitiveness, more productivity, lower the prices, and make the industry more efficient. So it helps the customers to buy power in a competitive market where it would have multiple choices, lower the economics of scale in power generation, so even smaller power plants would be able to produce electricity at the same price at which large size power plants would do. This is with an understanding that private businesses would be more efficient vis-a-vis government business. Costs obviously are expected to drop in the short run, if not in the medium term or the long run. However, in order to maximize profit and in order to provide quality power, there would be significant investments that would happen in the system, in research development, and it would eventually also help in improving the customer focus, because now the customer would have the choice to secure supply from whichever supplier it wants to secure power from. Quick question: in restructured industry, will the electricity and money flow stay unidirectional at all places, or will it become bidirectional based on the situation in place? Obviously, if power flow becomes bidirectional, money will also follow it accordingly. So if you allow electricity to travel in both the directions, you can both buy, you can sell electricity, then in that case, if you are buying electricity, you'll have to pay for it. If you are selling electricity, you'll get remuneration for that. You'll be remunerated for that. So if electricity is flowing, there are certain instances where electricity flows in the reverse direction, but You are right, but in those cases, some of those cases, the customers only get the benefit of the generation of the consumption that they of mitigating the consumption that they have not done. However, even if the consumers are injecting, even if the consumers are injecting into the grid, they do not get a remuneration for that. This was a scenario up till now. However, over the last couple of months, the situations are evolving. And now if you are injecting into the grid, even if you are a small consumer, if you are injecting into the grid, slowly discoms are opening up to the scenario in which they would allow the customer to be compensated for the power that it is injecting into the grid with certain terms and conditions. That helps. So rooftop solar grid connected, yes, that is a classical example. By injecting power, you can get, in some of the utilities, you can get compensated for the power that you are injecting into the grid. So that gives a bi-directional flow of not only power, but money also. Deregulation as a mechanism of industry governance has evolved both in developed countries as well as in developing countries. Developed countries, it was the driving force to provide customers with electricity at lower prices and offering greater choice in purchasing electricity. The role of regulator was in developed markets was essentially to improve the quality and the reliability of power, to ensure that significant technological investment starts happening. Vis-a-vis, when we talk about developing countries or not so developed markets, in those cases, the prime aim of deregulation was to ensure that there is sufficient investment into the system such that first, whatever is the demand, that is getting fulfilled. Second, inefficient managements are done away with. And third, the prices that the consumers, the tariff that the consumer has to pay, it is rational to the extent possible, and it is not irrational. Some of those which we see today, wherein rural consumer connected to the grid at a far off location is being provided electricity at 2 rupees per unit, whereas a large industry connecting to the grid at higher voltage level, which is very close to the network, where the network length is low and the voltage levels are high, still has to pay 12 rupees per unit. So this discrepancy of costs not getting reflected as prices, this is a significant challenge in developing markets. So their deregulation can help to rationalize the tariff and to ensure that the prices that the consumers pay are reflective of the cost being borne by the utilities to provide those services. Although in both the type of markets, it helps in bringing in new investment, it helps to improve the technology that is being adopted, because with the deployment of new technologies, obviously system efficiencies improve. It is not that this is a very rosy path with everything becoming good. That is not always the situation. There are challenges as well. Challenges because now all generators, they are participating as individual players. They are not participating as a group player. When individual players behave in the market, they behave in their own way. They are not bothered about what is the situation of the grid. They are not bothered about whether other players are able to fulfill their contracts or not. So in such a scenario, ensuring that all generators work and support each other to provide grid synchronism is a difficult task. They may operate in such a way that leads to the system touching its voltage and frequency limits. These generators may be playing with the market rules in order to maximize their profit. Along with those, control over those generators which are simply working based upon a certain profit motive, it becomes difficult to control their generation. It becomes difficult to physically enforce their bilateral contracts at the time of price fluctuations. So essentially, there is a lack of real-time control, leading thereby to situations wherein their operation may not be strongly targeted towards stabilizing the grid. Electricity, there are challenges in the sector because electricity, as we all know, it is a perishable item. It needs to be consumed then and there itself, as and when it is produced. So if you are producing power at that same point of time, you need to consume the power as well. Otherwise, the voltages would fluctuate beyond those defined in the grid code. And even if there are marginal variations in the demand and supply balance, that could lead to significant fluctuations in the prices and the prices of the commodity. So what would essentially be required is significant metering and real-time billing mechanisms. Obviously, that would require significant investment because presently, in the present schema of things, there's a lack of demand response. There are no customers who could respond to real-time fluctuations. So that creates a challenge for the regulators as well as for system operator to provide those services in an open market, because it will take some time before the markets really mature and provide services, all types of services as and when required in the most optimal way. Other than that, there are challenges of customer protection. The customer is now left over to the market prices. So you need to implement appropriate mechanisms to protect the consumer from any price volatility, which includes and is being practiced as price caps are being implemented by the regulators many times. It puts up a cap of 12 rupees per unit above which power cannot be traded in the exchange. It does that. Decision making is another challenge in a deregulated ecosystem because developing the ability to see long in the future and being able to decide which pathway is most suitable over a longer period of time, it is difficult to understand. It is difficult to visualize. So decision making at times could be a challenging process. And essentially, the governments and the regulators, they across the world, they face capacity challenges, human capacity challenges in doing decision making. One of the primary reason is that the observability in the market is limited with private players coming in, and coordinated control is all lost because the industry is now not working as a vertically integrated industry, but it is working as a deregulated, unbundled industry. So essentially, the regulator has to think about appropriate market design, appropriate coordination mechanism, and appropriate incentives to be put in place such that whatever resources are there in the system, they act in a timely fashion to respond to system imbalance challenges. They coordinate, the stakeholders coordinate with each other, despite that they may not find any economic benefit in that. But for the sake of grid security, they coordinate with each other to ensure grid stability. However, if appropriate market design is not in place, generators at a specific location may dominate and impact the prices of electricity in a certain geographical area. That could limit competition, result in higher prices in specific zones. However, this is something that the regulator has to see to ensure that such dominance in the market does not impact the stakeholders over a longer period of time. Obviously, the customers are exposed to challenges of prices and volatility and uncertainty, because now uh, the prices at which even the generator is buying, it varies significantly, and it may happen that the consumer may have chosen a supply pack which offers a volatile, which offers fluctuating prices, in which case, depending upon the demand supply, the prices may go up. It may impact consumer bills, making their budgeting and planning slightly difficult. Another challenge that we see, even while we have a regulatory infrastructure in place, uh, while it was a vertically integrated industry, coordination between different verticals was easy. So when I would like to plan a power plant, obviously, uh, as a power plant planning requires a time frame of 2 to 4 years. On a similar note, if you want to plan a transmission line, it may take anything between 3 to 7 years to put up a new transmission line. So essentially, I would always, as a utility, I would always plan my network before I start planning my generating capacity. However, in a restructured environment, that scenario is not feasible. And because generators are separate from transmission owners, so usually generators simply try to put up power plants without ensuring whether the network has got sufficient capacities or not. And that leads to bottlenecks, congestion in the network, which presently the Indian grid is facing recurrently in several states like Tamil Nadu, Andhra Pradesh, Gujarat, and Rajasthan. Even if there is an incentive, because of the time lag, new entities cannot enter into the market at short notice, and all investments would require a time frame. Further, other challenges like environmental concerns also, regulators are not able to handle those costs effectively if they do not have appropriate regulations in place. So that requires development of appropriate environmental regulations also, so that inefficient allocation of resources, not only in terms of money, but in terms of environment, is also ensured. Consumers, they have to be protected. So simply deregulating the industry does not help. You need to have appropriate pricing structure, appropriate contract terms, and multiple options for service providers, so that neither there is any information asymmetry for any stakeholder, and consumers could make informed choices. If you do not do that, deregulation may lead to a situation in which the consumers may be facing prices much higher than what they were being exposed to prior to deregulation or restructuring. Any quick questions on stuff we have discussed till now? Any quick questions? Else we move ahead to the next topic. I think I So after a quick I'll be happy if you have got any quick questions to deliberate. Else, before it gets too boring, I'll take you through the market design on a slightly quicker pace. I have a large number of slides yet to go. So essentially, not going into the theoretical background of things, but trying to keep it as practical as possible. We have power pools where you can trade electricity. So all those suppliers, generators who have got excess generation, who have got generation available, they could offer their commodity in the market, which would provide them opportunity to offer their bids at different prices, and the buyers could buy electricity in the pool at the prices that they are offering, wherever the selling price and buy price they match. There could be voluntary pools, there could be mandatory pools, depending upon the type of regulatory infrastructure is there in the system. So essentially, in a pool, the sellers and buyers, they submit their bid for amount of power that they want to sell or buy, along with associated prices at which they would like to sell, prices or the cost they would like to trade electricity. Sellers in the market would compete for right to supply energy to the grid and not for any specific customers. If they bid too high, they will not be able to sell it. Buyers compete for buying power. If the bid prices are too low, their bids may not be accepted. They would not be able to purchase. Suppliers draw power according to requirements, pay the pool price determined a priori or ex ante for volume that is realized ex post. So the quantum of power that is to be sold, that comes into their understanding later on. However, they may be asked to pay the pool prices which are determined beforehand. If it is unfavorable for a supplier to commit early by submitting bid to the pool, large consumers may be forced to do so. So in such a scenario, eventually the market dynamics drives the spot prices of the commodity electricity, which is a reflection of the marginal cost of efficient bidders in the market. In the market, winning bidders are paid the spot price, that is the highest bid of the winners. So depending upon how you are designing the market, it could be pay as bid or pay as MCP. The usually pay as MCP is a more prevalent option. Markets obviously they do not have a single design. The designs vary from country to country. It depends upon what is the size of the market, and there are no specific black and white features of these pools. But broadly speaking, when we talk about markets, it essentially is a scenario in which some of the features that I'm just reading it out, system operator, it dispatches the generation supply functions independently. System operator is closely associated with the transmission functions that based upon the transmission capacity available in the system, it dispatches the supply and demand. Dispatch is optimized usually on a day-ahead basis with no annual information held by the system operator. Dispatch optimization is done using simple information, using simple algorithms. Demand estimation is done so that based upon the demand, the suppliers can predict what would be the prices they would bid accordingly. Even the system operator can develop an understanding of how much would be the demand, and based upon which it could keep provisions for supply for contingencies as well, or for if there are likelihood that sufficient supply is not available in the system. Ancillary services, they may be provided either as a part of the grid code or through commercial agreements, or both. That means apart from providing power P, if you are expected to supply reactive power Q, there can be two forms. One, the generator may be forced to supply reactive power in certain quantities in a regulated form, depending upon the regulation being implemented by the regulator. Or in case there is a lack of sufficient ancillary services in the grid, or there is a lack of sufficient ancillary services with the regulated generators, they could also develop appropriate market mechanisms to provide those ancillary services through certain market mechanisms or commercial agreements. So both ways are possible. Presently, as we evolve from vertically integrated industry to deregulated, unbundled industries, the majority of the ancillary services are still being provided in a regulated fashion by the utilities. However, as things are evolving, the scope for providing these ancillary services through market arrangements would increase over a period of time. So we have got a variety of functions, features of the pools to talk about, though I'll not get into the details of those as we move ahead with the functioning of the pools. Essentially, in pools, they match the demand and supply bids and identify what would be the market clearing price, based upon which the dispatch of generators is decided. For large consumers, it makes value, but for small consumers, it is difficult for them to participate in pool because their capacity to negotiate is limited. So also if they are participating in the pool, they would be exposed to significant risk values. And these pools essentially do not provide any mechanism for demand management. If not the pools, electricity can also be traded through bilateral contracts. These bilateral contracts are between buyers and sellers. They are decided based upon their characteristics, are based upon the amount of time and the quantity to be traded. That is, at what time the commodity is to be shared, what time the electricity is to be supplied, and at what node it is to be supplied, and what is the quantity that is to be traded. Three forms are generally talked about. There could be customized contracts or one-to-one negotiated contracts in which we decide the quantum of power, the node at which it is being injected and or delivered, and the quantity on a case-to-case basis. Another form of trading is over-the-counter trading, in which companies or suppliers, they offer the product in certain quantities at predetermined prices, and buyers or customers buy those commodities without any negotiation at predetermined prices, as though you go into a retail shop and buy over-the-counter product without negotiating. In a wholesale market, you may negotiate, but when you go to a retail market, go to a retail shop, we hardly negotiate. So in the same way, in over-the-counter trades, we are not supposed to negotiate. Electronic trading is another form in which the same mechanisms can be in an electronic form, more transparent and faster trades. Bilaterals, obviously the trading counterparts are known to each other. The prices are opaque. What price you and me have contracted for, others do not know. Execution is lengthy and expensive because you have to negotiate with me. It may take some time, and these are, because it takes time, Usually these contracts are for longer duration. These are not short-term contracts. I'll not get into the minute details of the bilateral contracts. Usually these are long-term contracts. Prices are more or less stable. They help to develop capacities in the system because these are long-term contracts, and generators or other stakeholders, investors who invest into the system on a long-term time frame so that those capacities are available in the system. Power from various generating stations is contracted with the distribution businesses at determined prices based upon the historical cost-based tariffs. PPAs and all those are typically, they fall into the framework of long-term contracts. Short-term contracts can also be done for a shorter period of time. These are prices are more flexible. They are done for short period of time. The quantities obviously are smaller vis-a-vis large size contracts. Similarly, not going into the details of counter trading, over the counter and electronic trading. If you are into a bilateral market, obviously the prices are bilaterally negotiated. You can hedge your risk by not exposing yourself to the market. You enter the market at fixed prices and your prices would remain stable over a period of time. You could customize your contract as per your demand and as per your demand duration, as per the volumes that you require, as per the delivery locations, and as per the contract terms. It can vary. Whereas if you are participating in a pool, those things cannot be negotiated as such. Though bilateral markets, bilateral trades, they provide stability and predictability, and usually they are efficient. Usually they are efficient trades. The challenges are contractual risks. Renegotiation may have to be done at some time. Though these bilaterals, they do not provide you price discovery. They may not offer you the correct price. You may have to see the prices that you see may not be the true price of that commodity at that point of time. So there is lack of transparency, lack of visibility, and other stakeholders cannot make out anything out of it. What are the true market prices? So usually some independent reporting of the prices may be required so as to make the stakeholders provide more transparency into the bilateral trades. At some places, multilateral trades are also happening in which buyers, since they are small buyers, rather than getting into the negotiation spectrum, they ask a third party to do a contract on their behalf. So such type of ecosystem, such type of market mechanisms also exist in certain countries. Evolving down to, I'll take you to the spectrum where we start talking about the type of competition and type of markets that exist in the system. I may be skipping few of the things in the interest of brevity and in the interest that we are reaching the closure time soon. So regulated monopoly is what traditionally we have already seen. Purchasing agency model is something that we at times we see in the Indian market, in which I'll tell you just one example, wherein the state utilities, the state distribution utilities, Jaipur, Jodhpur, and Ajmer Vidyut Vitran Nigam Limited, rather than buying power in the wholesale market on their own, they pass on the responsibility to another entity, Rajasthan Urja Vidyut. They call it some Vidyut Development Corporation. I don't remember the name, but another entity which does the trade, which does the wholesale trade on their behalf. So this entity buys power in the wholesale market on their behalf based upon what their actual demand is, because individually these three entities do not have the capacity or do not have the willingness to participate in the wholesale market. This, they offer it, they trade through the wholesale purchasing agency, providing it certain percentage of commission for the quantum of power that is being delivered. So some places purchasing agency models, they work, though most of the deliberations that are happening in the industry, they are happening around wholesale markets as of now. This is the dominant spectrum of market that is operating, in which the generators offer their bids into the wholesale market, which operates over the transmission system. These generation companies can participate in the wholesale market. The distribution companies and large consumers can buy power in the wholesale market. Whatever trades are cleared, they are the power is transferred over the transmission system to those entities, which in turn supply power to the consumers, small or large, depending upon how they have contracted. So this is one spectrum of one type of business model in which the prices of electricity in the wholesale market are identified through appropriate competitive market mechanism. This creates an opportunity for the generators at least to sell the commodity at prices which are competitive. So at least on one side of the supply system, that is on the generation side, the prices become competitive, if not on the distribution side. In order to make, so there are benefits of wholesale markets. It provides a competitive platform, but the retail prices, they tend to be regulated. There are challenges in wholesale market. Vis-a-vis, if we go over to the retail markets, and this, which presently we hope some of the countries, some of the developed markets, they've already adopted. Some of the markets, they would are in the process. India is still in the process of adopting this. And this, apart from the GenCos participating in the wholesale market, rather than the discoms participating in the market, the retailers and large consumers would participate in the whole market, buy power in bulk, and sell that same power through a retail market to small consumers like you and me, and the power transfer would happen over the distribution networks. In this scenario, the customers would also have an opportunity to buy power from retailer 1, 2, or retailer 3, thereby creating competition at both ends of the electricity supply system, both on the generation side as well as on the distribution side. This creates a pressure on the GenCos to supply power into the wholesale market at cheaper rates. The retailers are under a pressure to buy power at cheap rates, and also to sell power at cheap rates, because if they do not sell it cheap, the customers would not buy. The customers would only buy power from those retailers which are selling electricity at lower prices. The pressure is always on the retailers to capture as large consumer segment as possible by offering the commodity at economic prices. And in order to do that, the retailers are under a pressure to buy the commodity at economic prices in the wholesale market, thereby making the complete chain of supply, bringing it into a competitive market framework. Though the stories do not end here, and even the retail market does not offer a very last mile opportunity for the consumers, because we all understand electricity, even if we create a retail market, the opportunity for the consumer to do trade on a short-term basis is not so sound. Once you have fixed a retailer, the type of contract that you have done with a retailer, you may have to survive with that retailer for a certain period of time, even if the prices that are being in the wholesale market may go down, but you will have to continue with the prices at which you have negotiated with the retailer. So that does not give you the opportunity to participate in the market and really benefit from the market prices. So in such a scenario, there is still an opportunity to create granular markets much beyond the retail markets that we talk about. These granular markets, we term them as local electricity markets, in which comprises of local consumers in a local area neighborhood, which can sell and buy electricity from their neighborhoods. This requires active participants which participate, interact, and involve in the supply system. They would have some local mechanism, some local mobile application or some application over which they are able to secure supply of locally generated power to local consumers over the local distribution network itself, rather than power traveling through the higher voltage transmission levels. So this reduces the flow of power over higher voltage networks, and there will be more and more incentive to produce local power for your neighborhood consumers, such that the utilization of higher voltage networks would be reduced to the extent possible. Though the design is complex and it is still evolving, but it creates opportunities in terms of small generators being able to inject power into the grid and small consumers being able to participate in the market, and also getting aggregated to provide various services like demand response into the grid. This would also require creation of entities like local grid controller or distribution system operator, which would manage the demand side responses, which would optimize the quantity being traded, which would do the local trading mechanisms and pass on only the residual demand up the network. The decision making and all those things can be done at the local level itself, rather than passing on the buck, passing on the responsibility to the higher voltage distribution systems or the transmission systems. Any quick questions if anybody wants to ask, or else we move ahead to the last end of the presentation. Peer-to-peer trading is obviously a mechanism that is visible on local energy markets. I'm not going into the deep depth of this, but giving you a superficial understanding. I understand a depth may take much longer than what we have thought of. So the content is there, but I'd like to just take you through those thoughts so that as you get into the next class tomorrow morning, you are more ready with a wider spectrum of things, wider understanding of the topics, rather than getting into the systems, getting into the ecosystem on a with a limited understanding of the system. While we develop local electricity markets, the structure of the system that you see is something that you see on this slide, in which at the higher voltage level, you have got the transmission network where the wholesale market would exist. At the distribution network, you would have the retail markets, and still below the distribution network, you would have local markets where consumers like you and me, who have got rooftop installed, would be able to interact with the market operator. Small generating units, they could also participate, they could interact with the market operator at the local level, do the demand supply contracts. Energy flows are indicated, consumers would be able to buy power from the local market operator itself. There are benefits, there are challenges. Challenges relate to the benefit is it would support creation of more demand response mechanisms. it would mitigate market power, it would help to provide ancillary services into the grid. However, this would also require significant smart grid interventions, significant investments in terms of appropriate metering arrangements in the system. The challenges, as I just indicated, there are technical challenges. The present grid does not support it in terms of because there are appropriate ICT infrastructure is missing, and in certain times congestion may start happening because appropriate monitoring mechanisms are still not in place. Market designs are still in a very immature shape. Appropriate policy and regulations are yet to come up. So, and also appropriate environmental, because a lot of this would be driven through battery storage, and presently there are environmental side effects of those as well. So possibly that needs to be focused upon. I'll not go into the depth of open access as well, because I understand open access is a mechanism. I'll just touch upon this. Open access is a mechanism to provide access over the network in a transparent way to optimize the resources. This is something fundamental to creating competition on the system. So while you are trying to create wholesale markets, this requires, or even retail markets, this requires creation of mechanisms by which networks could be accessed based upon a certain tariff design, based upon a certain set of charges that are to be paid for the network uses, such that all consumers who want to buy power over the network can pay the prices of the network users and buy power in an open access environment from faraway generators. This is an essential to creation of markets on networks. So it evolves from the Electricity Act of 2003. It creates opportunities for buyers and sellers. There are appropriate legal framework in place, which type of consumers can participate, how much would be the charges for the network users, what would be the charges for the losses, what would be the cross subsidy surcharges if they have to be paid for. So different charges are indicated. If required, we can deliberate upon this in some other course or some other class. There could be interstate and intrastate open access mechanisms, certain definitions related to open access, variety of categories of open access customers that can exist. I'll just skip these. This brings me almost to the end of the session, though there are a couple of more slides, but I'll be happy to answer questions rather than taking you through the slides. So one of the questions that I see on my screen is, how could AI applications into electricity market be explored towards sustainable development goals? When we talk about AI applications, obviously the number of nodes number of players or number of entities whose behavior is to be modeled should be large enough. So if you are using electricity markets, if you want to use AI, and if you want to target sustainable development goals, one of the mechanisms could be to develop markets for supplying maybe green power. And in order to supply green power, you could develop appropriate products in those electricity markets, which possibly focus only on green power, or some other form of electricity which fulfills some other form of electricity, or some electricity which has got characteristics towards fulfilling the sustainable development goals. AI applications, obviously, when we talk about AI applications, such systems we'll be talking about modeling the behavior of a large number of players. So these things could relate to, let's say, modeling the behavior and assessing whether the power that is coming, it is really green power or not. Something of that sort possibly we could figure out. Though this would be a slightly detached focus area. Three things in it. So if you're talking about AI applications in electricity markets, I think there are n number of those. If we talk about electricity markets towards sustainable development goals, this could be another segment to talk about. Specifically talking about AI applications to electricity markets, forecasting prices, forecasting the demand and supply. Those are some of the areas which require AI, significant AI applications could be there. Again, forecasting network availability and using AI, you could develop appropriate contracts as well. So yeah, there are a couple of opportunities in that segment. Any other question? If anybody has any question. I think we are.
You can raise your hand so that we can unmute you and you can ask your questions as well.
Yeah, if you wish, you can unmute if you are keen to ask a question in a verbal mode.
So, like, once they raise the question, then we can unmute them. So,
I must have a question, verbal question from one of you. Indranil, I hope you are listening to us. I just want to confirm if you are not sleeping. It is a risky proposition to have an online class. Could be somebody may be sleeping as well. So if there are any quick questions, else we close this session and move ahead for the sessions tomorrow morning. Gaurav has got a question, I guess. Gaurav, would you like to ask anything?
Sir, I asked it on the chat as well. Can you help us understand the reactive power? Means in overall system perspective, how?
Gaurav, I think the question is this a question from Gaurav? Please explain reactive power.
I mean, in physics
This
or
is
technical terms, yeah, I know it's a kid's concept, but in overall systems perspective, how does this, how big a role that plays?
can you repeat yourself, please?
Sorry?
Can you repeat yourself, Gaurav? I missed your question.
Sir, technically, I have an idea what reactive power means in circuits concepts, but in from the systems perspective and especially from electricity market perspective, how big or how where does reactive power comes into the network and how big a role does that play?
Very correct question. In fact, very important question. What has happened is when we used to have a vertically integrated industry, the responsibility of providing reactive power laid with the janitors who were a part of the vertically integrated industry. So the question of who would supply the reactive power never arose. It was presumed that the generator who is supplying P would supply Q as well. And since they were responsible for supplying, there was a single entity, they used to ensure that they also supply reactive power, which is required in the system to supply the reactive power requirement on the distribution side. However, as the system got restructured and the responsibility of the generators got limited to fulfilling their own contracts, and the contract specifically designed only to provide power P, that is leading to a situation in which reactive power, which is essentially required to maintain appropriate voltages in the system, because on the demand side, you are not curtailing reactive power. On the demand side, reactive power requirement would always be there. So in such a situation, to fulfill the requirement of the reactive power on the demand side, customers are still using motors. So reactive power has to be supplied. The power plants which are participating in the market, they don't supply. So somewhere down the line, the scarcity of reactive power is being felt. So over a period of time, not only reactive power, but other similar quantities like reactive power, like black start capability, some others as well, frequency support services, they are not available in the system. Generators do not provide them because they are not compensated for those. So essentially, this leads to a scarcity of those services in the grid, which now has to be provided through certain regulated or market mechanisms. Regulated mechanisms could include regulations like that the generator is asked to provide 10% of the capacity. It may be asked to provide that if you are providing 0.9 as P, you provide 0.1 as Q as well. Or it could be mandated that if you are supplying 1P, you keep a spare margin in your system so that you can supply the required Q as well as and when required. This is a regulated mode of ensuring that reactive power is supplied. Else, you could also have mechanisms by which, market mechanisms by which those commodities, reactive power is traded in the market. The system operator buys reactive power depending upon what is his forecast of the requirements of reactive power in the system. This leads to a scenario where two possibilities could exist: regulated supply of reactive power or ancillary services, or market driven approaches of supplying reactive power or the ancillary services. Both are possible, both are in practice as of now. Gaurav, does that answer your question?
To some extent, sir. Yes.
So
Yeah.
Still, if you have any doubt, let me know. What exactly would you like to know?
From generator perspective, how is reactive power different from the normal P that it has legal obligation to provide?
From a very fundamental perspective, what is the difference between active power and a reactive power?
Well,
you must have studied that.
Heat means normal power which gets dissipated as a heat means in terms of some heat load connected at the end of the other end of the terminal. And reactive power generally gets dissipated in form of either as inductance or a capacitive load.
A reactive power does not get dissipated. Reactive power keeps on oscillating between the generator and the demand.
Okay.
It leads to losses, obviously, because current is flowing, but it does not lead to any power transfer at any given point of time. The reactive power keeps on oscillating between the generator and the demand. And essentially, what from a generator's perspective, I'll put it in a very brief way for ease of understanding. From a generator's perspective, a generator has got a capacity of, let's say, 250 megawatt. Essentially, that reflects the generator can produce 250 megawatts of P. However, if it is expected to supply Q as well, then its capacity to provide P would reduce because it is dependent upon how much current can flow through the network. So essentially, it leads to a situation in which if it has to supply Q, then the compensation, the reactive power, the excitation of the generator has to be changed. And if the excitation of the generator has to be changed in such a way that it allows the generator to provide reactive power, and when we change the excitation, obviously its capacity to provide active power reduces. So thereon, it could be possible that it is supplying 240 megawatt of P and possibly a 10 megawatt equivalent of Q into the system. So that limits its capability to supply P, because the overall capacity to supply S, that is under root of P square plus Q square, is fixed. That is essentially how it affects their operation and economics in the system. That is how we understand it from the very fundamentals, that if there is a reactive power requirement that has to be supplied by the generators, that has to be supplied by changing the excitation of the generators.
I have one more question, sir.
Yeah.
We are treating electricity as a commodity, and just like any other commodity, are there any parameters with which we can ascertain the quality of electricity being provided?
Yes, we have parameters now. We have got parameters of voltage, we have got parameters of frequency. These are parameters by which we assess the quality of the product. Reliability is one.
Sorry, reliability.
Reliability, frequency, voltages, these are parameters which define the quality of power.
Okay, and
जैसे आप
overall,
आलू, जैसे if you go into the market and you say कि मुझे अच्छे आलू खरीदने हैं, what is that quality?
yeah. I was coming from
way.
that angle only, but
Yeah.
does power factor has a role to play, or any means to judge the quality of the electricity being provided?
I think power factor, yes, in a way, yes, we do want that the power factor should be limited. However, poor power factor obviously leads to more losses in the system, that we all understand. However, that does not deter us from treating reactive power differently. So even if there is a poor power factor in the system must have the capability to provide or compensate for that poor power factor by a variety of means. Either it is through compensation on the distribution side or through reactive power compensation being provided from the generation or the transmission side. Opportunities exist, though poor power factor is a matter of concern for the utilities because it leads to losses in the grid.
Okay, thank you, sir.
Thank you. I hope that helps. And we are into slight late evening in this part of the world. There are clouds around and it seems like it is almost night. So I'll thank all the participants, and I'm pretty sure tomorrow morning we'll have more interesting sessions with Dr. Satish and myself being here. So we close this session, Kush, if that works well. We close the session today and we catch up tomorrow morning at 10 o'clock. Thank you, everyone. Thank you, everyone.
Sure, sir. Thank you. Good night.
Good night.